Hi there, I'm Hao, and this is just another video of me solving random code problem. So today we have divide to integer. So given two integers, dividend and divisor, divide two integers without using multiplication, division, and mod operators. So the integer division is truncated to a zero. So if we have 8 point something divided by um, 3, right? We would have like 2 point something, and that would be truncated to 2, right? And then we are assuming that we have to return the quotient, right? Which is the results after we divide, right? And then we are dealing with an environment where we could only store 32-bit signed integer, so only negative 2 to the 31 to 2 to the 31 minus 1. Right? So this would be our mean int, right? And then max int, that would be negative 2 to the 31, right? And this one is 2 to the 31, right, minus 1. Okay, and we want to return the quotient. So let's set it to 0 here, right? Okay, and then what else? So how can we divide, right? So we can naive approach is that, for example, if you have right 10 divided by 3, right? We can subtract 3 from 10, right? Subtract 3, right? Until we have a negative number, right? Or we can subtract 3 until the dividend is smaller than the divisor, right? So that is minus of n, which is low because the n here is the number, right? It can go up to 2 to the 31 times, right? So another way we can do this is that we keep dividing the number by half. Sorry, yeah, keep multiplying the number by by 2, right? We can keep doubling the number. So let's say we have the dividend is 93706, right? So dividend is 93706, and divisor is 157, right? So previously, like every time we minus 3, we're gonna add 1 to the quotient, right? Remember, right? So we have 7 left, right? Minus 3 again, but the quotient become 2. Right, so we have 4 left, we minus 3 again, so the quotient become 3, right? And now one is smaller than 3, right? So we stop. So so every time we minus, we're gonna increment the quotient by 1, right? But in this case, quotient, right? Every time we double the divisor, right? Up until it reach the dividend, right? So every time we double the divisor, right, the power of 2, the quotient will also increase uh by by two times, right? So we can have let's see, yeah, we can have the quotient here. Yeah, I should write quotient. So we can start out at 1, I think. All right, so we can keep multiplying. So 157 multiplied by 2 is 157 multiplied by 2 is 314, right? 314, right? Multiplied by 2 again, we're gonna have 628. By 2 again, we have 1256. By 2 again, we have 2512. By 2 again, we have 5024. Multiplied by 2 again, we have 10,048. Divide by 2 again, we have 20,096. We have 40,192. Multiply by 2 again, we have 80,384. And then we multiply one more time, right? We're gonna have 160,000, right? 768, right? So this number is too large, so we just ignore it. It's larger than the dividend, right? So it is our highest double, right? Right. So this is the maximum time we can double, right? So what is our quotient? So every time we double the divisor, right, instead of minusing, we can double the divisor by adding the divisor to itself, right? Every time we double the divisor by adding it to itself, because we are allowed to use we are not allowed to use divide, multiply, right, and mod, right? But we can use add, right, and minus. So the quotient also increment by itself, right? We can double it by adding it to itself. So 1 plus 1 is 2, right? 2 plus 2 is 4. Right? A 16, 32, 64, 128, 22, 56, 512, right? Right? And this we don't care because yeah. Okay. So it means that it if we have this number, right? This number, um, right, divided by 157, we will have exactly 512, right? So again, we will have exactly 512 if we were to divide this number by 127, right? Which is our result, right? 512. And then we can take the remaining, right? So if we um, have 512 here, right? So we already have the result. If we take this number divided by 127, like our so our remaining gonna be we can take the dividend, which is 93706, right? We can minus by the the highest the highest double, right? Which is this number right here, right? Which is gonna give us the remaining, right, of 13,322, right? Okay, so and yeah, we can use this number and then divide it by the divisor again, right? Until we uh get the remaining down to a number that is less than the divisor, right? Okay, and if we go through the same process again, we have to go up until 10,000, right? Like this, right? This we have to take the divisor 157, and we need to double them again, right? Until we get to a number that is larger than the the remaining, right? Which is our new dividend here, which is right 13,000 here, right? So we're gonna stop at 10,000, right? Which is gonna give us 64, right? Right. And then we can add 64 to here, right? 64, right? We can add 64, and we minus the our remaining here, right? Which is 10,000, 10,048, right? We give us a new remaining of a new remaining of one, sorry, 3274, right? So we repeat the process, right? right? So we go to our divisor again and keep doubling it, right, until we got to a number that is larger than 3274, which is this part right here, right? So we stop here, and we with us a quotient, right, of 16. So we add 16 again, right, right, and we minus our highest double, right, which is 2512, right, which give us 762. And we just have to repeat the process here, right? 762. So we're gonna stop at this number right here, right? It will give us 8. So we add 8, right? Oh, it is not 8, right? It is 4. 4. It is 4. So yeah, that's 4. Right, this number is 4, right? Which, and then we're gonna minus the remaining, which is 628, right? We minus the subtract the highest double, right? So we're gonna have 134 left. 134, right? So we now we cannot repeat the process anymore, right? Because now the remaining is less than the divisor, right? And the 134, the allowance is just gonna be 10, right? So we just stop, right? And as you notice, the sum of this number, we're gonna give us 512 plus 64 plus 16 plus 4, gonna give us 596, right? It would be the result of our division. So as you notice, right? Finding the highest double gonna be log of n, right? Log of this number, because you can keep doubling it every time, right? But then we need to do we have to find the highest double again and again, right, on the remaining, right? And that is another log of n. So we're gonna have log square of n, right? It's very gonna stay constant, right? However, we can do a little bit of optimization here, because as you can see, we are kinda repeating ourselves, right? So the first time we stop at 512, right, which is here, and the next time we stop at 64, right, which is here, here, right, and the next time we stop at 16, which is right here, right, 16, right, and the next time we stop at 4, right. So as you can see, let me change the color on the green here, right. This part is keep being repeated, right, 3 times. So that is not very efficient. So what we can do is that instead of doubling again, we can do something else instead. We can, after we find the highest double, right, and give the value here, right, we can divide the highest double by half until we get to a number that is smaller than the remaining, right? So let's say, for example, our remaining, our first remaining, if you recall, gonna be minus, gonna be, let me see, so gonna be 13, 322, right? So this is we're gonna be our first uh remaining, right? So 13, 322, right? 13, 322, right? It is after we add the 5, it is our uh new remaining, like new dividend. You want to think about it that way. And then so we can keep divide this number in half, right, again and again, until we got to a number, right, that is smaller than our remaining, right, which is here. And then we can add 64, right? We can keep going until we got to 16 again, right? Add 16, right? And then we keep going. So every time we find a dividend that is larger than the highest double, right? Right. Every time we find the dividend, right, the remaining, which is the new dividend, is larger than the highest double, right? It is dividing by half again and again. If we find the value of the dividend is larger than the highest double, then we can add the highest power of 2, right? Which is the quotient here, right? The highest power of 2, highest power, right, to our quotient result here. So this should be our quotient here, right? Right. And every time we add to the quotient, right, we have to subtract our dividend, right, our remaining, which is our new dividend, with the highest double, right, to get the new remaining, and then we can keep going. So in this way, we only do 2 loop, right? So that is O log 2 log n, right, which is just O of log n. Okay, so we don't have to do a repetitive work here. So another thing is that remember that we are not allowed to use divide, right? So how can we divide a number in half, the highest double in half? And the answer that is that we can shift 1 bit, right? Shift right by 1 bit. So for example, if we have 8, right, which is represented in binary, gonna be 1000, right? If we shift right by 1 bit, I'm gonna have 0100, right, which is 4, right? So every time you shift right, you can divide the number in half, right? And as you divided the divisor by half, right? As you iterate backward, you also need to divide the current power of 2, right, by half. So when you add the quotient, you can add the correct number. Okay. And yes, that is our whole algorithm. We can do it in O log of n, right, and then O1 space. And another thing I want to mention is about the edge case. So um, so if, right, the dividend is equal to the min int, right, and the divisor is equal to -1, right? We're gonna have integer overflow. Why? Because this will be our largest, this will be our minimum int, right? So gonna be 2, 1, 4, 7, 4, 8, right? 3, 6, 4, 8. But our positive bound, our upper bound gonna be only for 7, right? Because of the -1 right here, right? So this number, right, is a valid number that is represented in a 32 side integer, 32-bit side integer, right? It is totally valid for a negative number, right? If you recall here, right? So if we have the dividend is equal to the minimum int, which is this number right here, and if we multiply it by -1, right, it's gonna give us positive 2 to the 31, right? So in that case, we have integer overflow, right? And as mentioned by the instruction, right? If we have anything greater than or lower than greater than the upper bound, right? We need to return the maximal is the upper bound, right? We cannot return this number. We need to return the max int if we have overflow. So that is the one edge case that we need to remember. Okay, so that is all I want to say. So let's put this up. So we have our min int and our max int here, right? Already. So we need to check our oh yes, and one more thing, negative numbers, right? We have 4 cases, right? Negative, negative, positive, 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 negative, and negative, positive, right? So our strategy is pretty simple. We just turn everything into positive and keep track of the side, right? the dividend is positive and the divisor is negative, right? Or the dividend is negative and divisor is positive, right? Plus minus or minus plus, we will return a negative quotient at the end, right? But when we calculate our result, we only do it in positive, right? We can turn everything, we can turn both the dividend and the divisor into a positive number. We can keep track of the side, right? So we can do is negative, right? Equal to with the dividend is less than zero, right? And the divisor is greater than or equal to zero, right? Or the divisor is greater than is less than zero, right? And the dividend is greater than or equal to zero. So this is the only two cases when we have negative, right? If both of them are minus, they're cancelled out, right? If both of them are plus, then this is positive, of course. And then at the end, we can return, right, the quotient, right? We can check the side. If it is negative, we're gonna return the minus quotient. Otherwise, we're gonna return the positive quotient, right? Right, and then because we already stored the side, right? The flag here to keep track of the side of the result, right? We can turn everything into positive now. So if dividend is less than zero, right? We can set the dividend is equal to the minus dividend. Yeah. If same thing for the divisor, right? Okay. And then so that is it about the sign, right? The plus and the minus negative number. And now we need to take care of the integer overflow, right? So we can do integer overflow, right? Our special case. So if the dividend, right, as I mentioned earlier, is equal to the mean int, right? And the divisor is equal to -1, if we want to, we're gonna return the maximum, right? Because we have integer overflow here. We don't care if the divisor is larger than the dividend, because for example, if you divide, like you take 1, you divide it by 10, right? You're always gonna get 0 because everything is truncated anyway. And so that is our only our edge case there. Next, we need to find the highest, right? By the highest level, right? There, and the highest power up to. Okay. So we get we can let the highest double equal to the divisor, right? So we keep doubling the divisor, right? Until we get a large enough double, right? That is greater than or equal to the dividend. And we can set out the highest double, highest power of 2. Equal to 1, right? So y highest double plus highest double. Right, remember, I cannot use the multiplication here, right? So only plus and minus in this case is less than or equal to the dividend, right? So if we double the number and it is still less than or equal to the dividend, then we will do it, right? So highest double plus equal highest double, right? We are not allowed to use multiply here. Highest power of 2 plus equal highest power of 2. Okay. And yes, let's double check, right? Just make sure we got the correct number as we expected. Right? The highest double and then highest power of 2, right? We expect to get 512, right? Yeah, 512 for power of 2, if you recall earlier, right? And 80,000 for the highest double, right? So here we have 80,000, right? And then 512, right? 80,000 here. Where's my pen? 1 second. Here, 80,000, right? And 512. Okay, and then now we need to go backward, right? And then keep divide the highest double, right? The highest double, the highest double in the highest power of 2, right? By 2. to equal less than or equal to sorry, greater than, right, or equal to our divisor. Sorry, greater than or equal to our highest double, right? Right. So our dividend is 93,000, right? So we want to keep divided by 2 until we get a highest double, right? It is the highest double, right? A highest double that is less than, right, or equal to our dividend. And then we can subtract the dividend. We can take the dividend and then subtract it from the highest double, and then keep going from there. Okay. So let's do that. So what are we going to do here? We will find a function, right? Find a function. Right? So y, the dividend, right? For the dividend is greater than or equal to the divisor, right? So the only case, the only condition when we stop is when we have the remaining, which is the new dividend, right? The remaining, right, which is the dividend, is less than the divisor, right? Which means we can no longer divide, right? So we just break the loop. So you can check, right? If the dividend is greater than or equal to the highest double, right? The dividend is our remaining the new dividend, right? If it's larger than the highest or equal to the highest double, which we can divide, right? So we can do quotient a plus equal to the highest double. Wait, no, highest power of 2, right? Because this is gonna be our quotient, highest power of 2. So every time we double up the divisor, right? We also double up the power of 2. Okay. Okay. And then if the dividend is larger than or equal to the highest double, we add the result, right? And then after we add the result, we need to subtract, right, the dividend from the highest double, right? We subtract the dividend from the highest double so that we can get the new remaining, right? Right. So while the dividend is larger than the divisor, right? Which means the dividend here, the remaining here, right, is greater than the divisor, which is 157. So if the dividend, right, this number, right, is larger than the highest double, right? If it is larger than, and it is larger, right? So we add the quotient to the highest power, right? Which is 512 here. We add 512 here. Right? After we add 512 to there, we need to decrement the dividend, right, which is this number by 80,000. So we're gonna get 13,000 here, which is our new dividend, right? New dividend, our remaining, right? And then the only thing left to do now is we need to divide this by half, right? And divide this by half by uh, bit shifting. Okay, so we can divide it by half by highest double, right? Keep it by 1, which to we divide it by half, also the power of 2, right? Right. So when we are shift are divided by 2, right? We so remember our remaining gonna be 13,000, our new remaining, right? So we're gonna keep going, right? We're not gonna always add to the quotient, right? We only add when we find a highest double that is less than the new remaining, right? Our dividend, right? So we're gonna go to 40,000, 20,000, and then 10,000, right? That is when we find a highest double, right? That is less than or equal to, right? Less than or equal to the new dividend, which is 13,000. So that's why we add to, for 64, and then keep repeating. And yeah, that's pretty much it for this problem. Let's give it a try. Okay. it worked. Thank you for watching.